Good morning and welcome to the webinar Higher Performance Through Drive Simulation, Solving Critical States of the Servo Hydraulics Efficiently. My name is Matthias Beetz and I will be presenting today's webinar. Your speakers are Philipp Gebhardt regarding applications.
Good morning.
And the simulation engineer Stefan Hecht.
Hello.
They will be holding the webinar and answering your questions at the end of it. In today's webinar, you will find out how ProSimulation helps you in the engineering process, the advantages of ProSimulation, and how to use ProSimulation profitably in servo-hydraulic applications. Before we get started with our webinar, I would just like to point out that you will be muted during the webinar. However, you can still ask us questions during the webinar using the chat function. The questions asked in the chat will then be answered at the end of the webinar in a question and answer session. We have planned around 5 up to 10 minutes for this. We will be recording the webinar and you will be sent a link to the recording later in an email. A few brief words about Baumüller. Baumüller is a global family-owned company with more than 90 years of experience in its core business, drive and automation systems, which are used in many industries. And now, I hand you over to our speaker, Stefan Hecht. Stefan is an expert in the simulation and dimensioning of drive systems in industrial automation. I hope you find the webinar interesting. Enjoy it.
Thank you, Matthias. To begin with, I would like to present the agenda for today's webinar. To get the webinar started, I will give you a brief introduction to the topic of Baumüller ProSimulation. Then, in the ProSimulation in Servo-Hydraulic Applications chapter, Philipp will present the use cases of servo pumps in ProSimulation. We will end the webinar with a summary and a round of questions. Let's start with a brief introduction to our simulation tool for drive technologies, ProSimulation. Why does it make sense to use a simulation tool for drive technology? Nowadays, mechanical engineering has many challenges to deal with. On the one side, shorter innovation cycles, reduce time to market for new machines, and stay competitive. On the other side, we have high cost pressure, economic difficulties, and limited manpower in your company. The goal is now to keep both sides into equal. So that means you can have shorter innovation cycles and also do not have large cost pressure. One possibility for doing this is provided by the digital twin and the simulation with ProSimulation. Here, ProSimulation enables you to improve your time to market, shorten your innovation cycles, and also stay competitive. You will find out how this is possible in the following slides and also in Philipp's turn. But first, what is ProSimulation and what advantages does it offer for you as a user or a customer? ProSimulation is a simulation tool for designing, optimizing, and commissioning of drive components, especially from Baumüller. So with ProSimulation, you are able to design drive and automation components, do virtual commissioning, and also troubleshooting and optimization of existing machines and systems. Because we are just in a virtual world, you can test and optimize different data sets or settings on the drive and the machine without the risk of damaging your machine. Also, ProSimulation enables an easy start into the simulation because we have already made models that allows you to build up a quick simulation. So you have to just drag and drop, for example, a source for the speed, our controller and motor model and the mechanics model, connect the three models together, and then maybe you're ready for your first simulation of your machine. It's also no complex modeling necessary, and ProSimulation is completely integrated into our engineering tool ProDrive. With ProDrive, we commission our drive systems, and so you have the same graphical user interface for the simulation as for the real machine. And also you can use all data analysis functions of our ProDrive tool. I would like to give you a little bit more in detail information about the use cases of ProSimulation. The first use case is the model-based design or model-based sizing. We can use ProSimulation to do an accurate sizing of the drive system. We see a benefit in using ProSimulation for sizing complex systems such as nonlinear kinematics and also systems with energy storages like servo press systems. Another point is take the dynamic system behavior into consideration. For example, in applications with big inertia mismatch or in servo hydraulics application, which will be presented by Philip. Of course, it's not necessary to use the simulation in standard application or standard sizing tools, for example, like extruder applications. The second use case is virtual commissioning. Here, the main benefit is that you have no sequential engineering, as you can see in the upper part of the with a step-by-step phase. You can test your machine components and the corresponding PLC code already in the virtual world, and even though the real machine is not built up. So this enables you to shorten the complete engineering process and therefore save time and money, and also shorten your development time of new machines. The last use case is the use case for digital twin during the operation. This means during the operation of the machines, we are able with the digital twin to do training for personnel and also service support. In the future, there's the plan to use the digital twin also for predictive maintenance, that you can compare online the behavior of the simulation and the real machine. If you would like to get extended information about the use cases of ProSimulation, we have 2 white papers available. On the first white paper, the simulation technology in drive dimensioning is most corresponding to the model-based sizing. And the second white paper, drive simulation, a silver bullet, there we describe 5 different applications and how we use the simulation in these applications. And now I will hand over to Philip, who will give you the possibilities and advantages of ProSimulation in servo hydraulic applications.
Thank you, Stefan. Also from my side, a warm welcome to all of you today. Stefan, I think you've already summed up my topic quite well. I would like to give you an overview in this webinar about the advantages of ProSimulation, especially in servo hydraulic applications. And for this, first of all, let's have a look at a typical structure of a servo hydraulic application. This application typically consists of an overlaid machine control, which is supplying our BMX 5000 drive with 2 set values. First is the pressure set value, and second is the volume flow set value. Our BMX 5000 drive is then doing the pressure control and volume set control inside the drive directly. Of course, we also have a servo pump and a servo motor, which is basically the same as shown here on our test bench. The servo motor runs in speed-controlled operation and is doing the pressure control by adjusting the motor speed. And the internal gear pump has a fixed displacement volume and is so changing the volume flow with the motor speed. Of course, we also have a pressure sensor inside the system, which is directly read in by our BMX 5000 drive via an analog input. Of course, we also have some hydraulic customers, which in today's example will come from an injection molding machine. And if we have such an application, we can mainly benefit by using ProSimulation in 4 things: in an efficient component design, in an optimized machine behavior, in a faster commissioning process, and in the improved service quality. And for all these points, I brought some use cases today, which I want to show you. But before I come to the use cases, I want to give you a short view inside the software. How does the software look for the end user? What we can see on this slide is on top the components of the real system, and below how they are abstracted in the model. And starting on the left-hand side, we have the machine control, where the set values coming from the machine control are basically imported using CSV files, which are then connected to a special software block, which is the software option servo pump, which is an optional software which can be chosen for BMX 5000 drives, which is doing the pressure control and the volume flow control. This special software block is then giving us the speed set value for the main part of the model, which is the controller model and the motor model. They are inside one single block in the middle of the system. The motor torque is given out from these blocks and is given to the hydraulic system block, which is mainly the hydraulic pump. And from this block, we can read in again the actual values, which are the position value, the actual speed, and the actual pressure in the system. Using this model, we can now simulate the first use case, which is simply a pressure step. And this pressure step, we can now simulate with different components. And if we compare, for example, a classic motor pump combination with a high dynamic Baumüller motor pump combination, which is consisting of a DSD2 motor and a QXE-HX hooker pump connected in the performance line direct mounting, we can see that we have a much higher acceleration capacity, a faster control behavior, and less braking power, which has to be converted. And in this way, we can choose the components and optimize them for productivity, process quality, and efficiency, even at a very early development stage. The second use case I brought today is an example for offline dataset optimization. Here in this example, we have a customer application which has a switchable hydraulic accumulator. When this accumulator is switched on, it is pushing back the cylinder, and the pump has to work in regenerative mode to reduce the pressure coming from the accumulator. And for this special use case, it is a nice example for the offline optimization, because for this special case, the default settings are not optimal, which we have usually in the drive. And as we can see from the blue line on the left-hand side, the actual pressure had a deviation of 18 bars with the default settings. And you can very easily now optimize the controller settings by trying out different settings offline using ProSimulation without the hazard of damaging the machine. And so we found very easily a new setting which was reducing the deviation to 3 bar. And thanks to the same interface of ProSimulation in the simulation and the dataset on the drive, we can very easily download the optimized settings directly from the ProSimulation software inside the drive and provide a quick and easy support for colleagues on the customer side and reduce the time on the commissioning by a lot. The next use case is very interesting, especially for injection molding machines with long pressure holding times, because especially in injection molding machines, internal gear pumps are very often used because they have many advantages, such as a low pressure pulsation, a low noise, and a high efficiency. But unfortunately, internal gear pumps also have one disadvantage, and this is they cannot operate at high pressure and very low flow for long times, because otherwise the pump becomes thermally overloaded. And so we have usually times slots, how long they can be in this operation point, and has to be switched then back to another operation point. And for these special operation points, the Baumüller drives offer a special software function, the so-called thermal pump projection, which determines the thermal pump load of the pump by the actual values of the system, and if necessary, switches a bypass valve that increases the oil flow through the pump and ensures a better heat dissipation through the higher oil flow. This allows the operation point to be shifted from the temporary operation range into the continuous operation range. And now these functionalities are also available in ProSimulation, so it can be used to quickly and easily determine if a thermal overload of the pump can occur in the system or in the machine cycle, and how it can be prevented. For this purpose, the thermal overload block can simply be added inside the simulation model, here on the right end of the model, and it is supplied with the actual pressure and the actual speed of the pump, and outputs the actual pump load and then signal for the bypass control. When the bypass control is deactivated, critical operation points with possible thermal overloads can now be very easily detected by exceeding the 100% threshold. And here, for example, at 24 seconds, a thermal overload is reached, which means we are outside of the data sheet specifications from the pump. By activation of the automatic bypass control, ProSimulation can now be used to estimate the required bypass flow and to optimize the machine cycle that an overload is not present. And as can be seen from the green line in the middle, the bypass valve is only enabled when the pump load exceeds the threshold. So at 24 seconds, we see here that the speed increases, which means the bypass is open, and it is closed with the next set value change. And for the rest of the cycle, it stays closed. So no unnecessary hydraulic losses are generated, and energy is saved to a compared solution which has a constant open bypass, which are also present in some machines. The last use case I want to present is a use case for the service support. In this example, the customer complained that the pump could not longer reach its maximum pressure. And by comparison of the simulation on the one hand and the reality measurement on the other hand, ProSimulation indicates a considerably increased motor current on the machine. And by reconstructing this error using the ProSimulation, the cause of the error can be found very easily and can be determined in the encoder mounting here. And so the service personnel can be supported with a solution approach in this way, and the troubleshooting can be accelerated and the downtime of the machine can be reduced. Yes, finally, I want to summarize the advantages once again. Basically, we can say ProSimulation can be used in the complete engineering process, but especially ProSimulation will support you in the sizing and design process, because ProSimulation can, in contrast to conventional design tools, also consider dynamic effects, such as pressure buildup times, for example, and the transient behavior of the system. This means that more detailed statements about the cycle times are possible, and also that we can say, or that we can have more detailed statements about downsizing possibilities. In addition to that, the machine behavior can be optimized by the simulation on a digital twin without the hazard of damaging the machine. And this also helps us during the commissioning process, because with the virtual creation of the datasets, we can reduce the commissioning time, because we already have a ready dataset before we are at the machine. And the same is true for the supporting the service at the machine, and because here we can identify the causes of errors and faults more quickly and reduce the downtimes by comparing the simulation and the actual condition at the machine. And furthermore, by simulating wear and aging influences, for example, we can also develop new strategies, for example, for preventive maintenance applications. Yes, with this, I want to give back to Matthias, who will now read your questions inside the chat. Matthias, do we have any questions inside the chat?
Thank you for your interesting presentation, Philipp and Stefan. Yes, we have some questions. The first question is, what does a license model look like and how much does it cost?
Yeah, Stefan, maybe do you want to say something about that?
I do something. For the license model, we have a single user license. This means we have a license who is coupled to or he is connected to the hardware of you, for example, your notebook. And this is a single user license. You have to pay it just one time, and then you get the ProSimulation, for example, with the drive and motor model, the sources, for example, a CSV file, as Philipp mentioned, for importing speed or position, and also some basic mechanics like the two-mass oscillation. Then we have additional components like Philipp presented, the servo pump software or the servo pump mechanics. These models are extra and have to order extra and paid.
The next question we have, how long does it take to set up the simulation?
Say something about special servo-hydraulic applications. If we have a very easy application, only consisting of a pump and a cylinder, they are already made models and can be set up very easily. I think maybe half an hour and you have simulated your system. If there are complex systems, as we see with this accumulators which are switched on and off, it depends on how detailed you want to model your system, but then it can be even a little bit longer. But the benefit on the one hand is that you have the common ProRef interface to create your data set and things like that. And so you have not a new interface which you have to learn. you already know the interface, and on the other hand, there are already made models which can be used, so you don't have to create a model in detail first, because you can use the ready-made models from our library.
And we have a next question for ProSimulation again. How long does it take to install ProSimulation?
I think it's my turn. ProSimulation is completely integrated in ProDrive. As Philip described, we use the same interface. ProSimulation is just an add-on on ProDrive. So the main effort is to install ProDrive, our engineering tool, and then you have to just order ProSimulation. Therefore, you get an installation license. This license you have to import in ProDrive, and then you can build up your first simulation. So maybe I think also around half an hour, then the installation is done.
And we have a last question at the moment. Please feel free to ask us your questions. How can the simulation be validated by a real measurement?
Yeah, maybe I will say something to that. We have a special oscilloscope block inside the model where ProDrive measurements can be imported directly inside the model. And yeah, with this oscilloscope block, you can directly fit your model settings to the real measurement by comparing the oscilloscope graph from simulation and the real measurement inside one tool, inside one window, directly with the same timeline.
We have another question. Generally, on a simple application, how many settings are needed to be set up for the simulation to work?
For servo hydraulic applications, we have special guided commissionings inside ProDrive. So if you're using our BMAX 5000 drives, maybe you know them already. If you use ProDrive, there's a special wizard inside ProDrive for servo hydraulic applications, which are already giving you default values, and which will guide you step by step through the commissioning process. And these guided commissioning processes can also be used in ProSimulation to create a first data set. So you don't have to input all settings by yourself, because it will do the guided commissioning for you. So it will be guided step by step through the first data set creation.
Yeah, we have no any further questions. We are at the end of the webinar. If you have any further questions after the webinar, please feel free to send us an email at marketing@baumüller.com, and we will then answer your questions afterwards. Further interesting information about our webinar can be found on our website under Baumüller Insights. We'd love for you to join us again for a future webinar. At this point, thank you so much again to my colleagues with a very interesting information, with a perfect webinar. Thank you very much for your attention and for participating at this webinar. Yeah, at the end, we say goodbye from Nuremberg, from the Technicum in the Baumüller Academy at our headquarters. And a very important point for everybody, please stay healthy and hope seeing you and hearing you again. Goodbye from Nuremberg.